A resistor is a passive electronic component that limits the flow of electrical current in a circuit. Resistors are commonly used in electronic devices to control the flow of current and voltage. Here are some important facts about resistors. Resistance is measured in ohms. I circumflex copyright, which represents the amount of resistance that the resistor offers to the flow of current. The higher the resistance, the more it resists the flow of current. Resistors are made of different materials, including carbon composition, metal film, metal oxide, and wire wound. Each type of resistor has different properties and is used for specific applications. Resistors have a tolerance rating, which indicates how much the actual resistance of the resistor can deviate from its nominal value. The most common tolerance values are 1%, 5%, and 10%. Resistors can be connected in series or parallel to create different resistance values. When resistors are connected in series, their resistances add up. When resistors are connected in parallel, their resistances decrease. Resistors can generate heat when current flows through them. The power rating of a resistor is the amount of power it can safely dissipate without getting damaged. Resistors can be used for a variety of applications, including voltage division, current limiting, and signal conditioning. Overall, resistors are an essential component in many electronic circuits and are used to control the flow of current and voltage. Resistors are significant components in electronic circuits for the following reasons. Voltage and current control. Resistors are used to control the voltage and current in a circuit. By adjusting the value of the resistor, the voltage and current can be controlled to match the requirements of the circuit. Current limiting. Resistors are used to limit the current in a circuit. In some circuits, it is important to ensure that the current does not exceed a certain value, which can be achieved by placing a resistor in the circuit. Signal conditioning. Resistors are used for signal conditioning in electronic circuits. They can be used to match the impedance of a source and a load, to create a voltage divider, and to filter noise from a signal. Biasing. Resistors are used for biasing in electronic circuits. In transistor circuits, resistors are used to provide a bias voltage that establishes the operating point of the transistor. Temperature control. Resistors can be used for temperature control in circuits. Some resistors change their resistance with temperature, and these resistors can be used to sense or control temperature in a circuit. Component protection. Resistors are used to protect components in a circuit from excessive voltage or current. By placing a resistor in series with a component, the resistor can limit the voltage or current that flows through the component. Overall, resistors are a fundamental component in electronic circuits, and their importance lies in their ability to control, limit, and condition electrical signals. The value of a resistor can be determined by reading the color code or by using a multimeter. Here's how to do it. Reading the color code. Most resistors have color bands painted on them that indicate their resistance value. The color bands are read from left to right, with the first band being the one closest to one of the leads. The colors correspond to the numbers on the resistor value chart, which can be found online. Here's how to read the color bands. First band, this is the first digit of the resistor value. Second band, this is the second digit of the resistor value. Third band, this is the multiplier that determines the number of zeros in the resistor value. Fourth band, this is the tolerance of the resistor, which indicates the percentage by which the actual resistance can vary from the nominal value. Using a multimeter. A multimeter is a tool that can measure the resistance of a resistor. To use a multimeter to determine the value of resistor, Follow these steps. Turn on the multimeter and set it to the resistance, ohms, mode. Touch the leads of the multimeter to the two ends of the resistor. Make sure there is no contact between the leads. Read the value displayed on the multimeter. This is the resistance value of the resistor. It's important to note that some resistors may be damaged or have degraded over time, which can affect their resistance value. In such cases, it may be necessary to replace the resistor. Resistors can be made from various materials depending on their intended use and performance characteristics. Here are some of the most common materials used in the construction of resistors. Carbon composition. These resistors are made from a mixture of carbon powder and a binder material, such as ceramic. They are relatively inexpensive and can handle high power, but their tolerance is generally lower than other types of resistors. Metal film. These resistors are made by depositing a thin film of metal, such as nickel or tin, onto a ceramic substrate. They are more precise and stable than carbon composition resistors and are commonly used in precision applications. Metal oxide. These resistors are made by coating a ceramic substrate with a metal oxide, such as tin oxide or zinc oxide. They have a high power handling capacity and are commonly used in power applications. Wire wound. These resistors are made by winding a wire, typically made of a resistance material such as nichrome or a copper-nickel alloy, around a ceramic core. They are able to handle high power and have a high level of precision. Thick film. These resistors are made by depositing a thick layer of resistive material, such as ruthenium oxide or cermet, onto a ceramic substrate. They are relatively inexpensive and have a high level of precision, making them ideal for a range of applications. Overall, the choice of resistor material depends on the requirements of the specific application, such as power handling capacity, precision, and cost. Here are some advantages and disadvantages of resistors. Advantages. Control of voltage and current. Resistors provide control over voltage and current in a circuit by limiting the flow of electrical current through the circuit. Easy to use. Resistors are relatively simple to use and install in electronic circuits, making them a popular choice for engineers and hobbyists. Wide range of values. Resistors are available in a wide range of resistance values, which makes them versatile and suitable for use in a variety of different applications. Stability. Many types of resistors, such as metal film resistors, are known for their high stability and ability to maintain their resistance value over time. Low cost. Resistors are generally inexpensive and readily available, making them an affordable component for use in a range of different applications. Disadvantages. Power dissipation. When current passes through a resistor, it produces heat due to the resistance of the material. In high power applications, this heat dissipation can become a significant issue, requiring additional cooling measures to be taken. Tolerance. The resistance value of resistors can have a certain level of tolerance, which means that the actual value of the resistor may be slightly different from the specified value. This can be a problem in some applications that require a high degree of precision. Noise. Some resistors can introduce noise into a circuit, particularly if they are not properly grounded or if they are exposed to electromagnetic interference. Size. In some applications, particularly in compact electronic devices, the size of resistors can be a limiting factor due to their physical size. Nonlinearity. Some types of resistors, particularly those made of carbon composition or wire wound materials, can exhibit nonlinear behavior, which means that their resistance can vary depending on the current passing through them. This can be a problem in applications that require precise control of voltage and current. Resistors are commonly used in electronic circuits for a variety of purposes. Here are some of the most common uses of resistors. Voltage division. Resistors are often used in voltage dividers to reduce the voltage of a signal or to create a reference voltage for use in other parts of a circuit. Current limiting. Resistors can be used to limit the amount of current flowing through a circuit, which can be important for protecting other components from damage or for ensuring that a circuit operates within a safe range of values. Biasing. Resistors can be used in biasing circuits to establish a certain level of voltage or current in a circuit. Timing. Resistors can be used in timing circuits to determine the length of time that certain events or actions occur within a circuit. Filtering. Resistors can be used in conjunction with capacitors to create filters that remove unwanted frequencies from a signal. Temperature sensing. Some types of resistors, such as thermistors, can be used to sense changes in temperature and provide an output that varies with temperature. Feedback. Resistors can be used in feedback circuits to provide a signal that is proportional to the input signal, which can be used to control the behavior of other parts of the circuit. Overall, resistors are an essential component of many electronic circuits and play a critical role in controlling the flow of current, establishing voltages and currents, and creating signals that can be used for a variety of purposes.